The Collatz conjecture, also known as the theorem plus 1 problem or the Syracuse problem, is a famous unsolved problem in mathematics. It concerns the behavior of the following iterative sequence. That is, for integer n, if it is an even number, we're going to divide it by 2. If it is an odd number, we're going to put it theorem plus 1. So that is sometimes referred to as the theorem plus 1 problem. Alright, we're going to repeat this process with the new value of n and continue until we get n equal to 1. For example, I have a JavaScript program here. Let's try number 6, and then 3n plus 1, and then so on and so forth until you get 1. Alright, so this one states that no matter what positive integer n we start with, the sequence eventually going to end up with 1. Despite its simplicity, the conjecture has remained unsolved for over 80 years, and it continues to be an active area for research. Many mathematicians have tried to prove or disprove the conjecture, and while there are some partial results and the related theorem, no one has yet been able to settle the question definitely. Alright, so to get a sense of the complexity and unpredictability of the sequence, let's consider another example. For example, let's say 5, right? So 5, you're going to see that it ends up with 1 in just a few steps. Let's try 11. 11 here, and the sequence is a bit longer, right? So basically it varies widely even with small numbers. One interesting aspect of the Collatz conjecture is that it seems to exhibit a kind of randomness or chaos, even though the sequence is entirely deterministic and its behavior is governed by a simple set of rules. There are no apparent pattern or regularity that allow us to predict its behavior in advance. Despite its apparent randomness, the sequence has been studied extensively, and many interesting properties and patterns have been discovered. For example, it is known that the sequence always contains a power of 2. One of the challenges in studying the Collatz conjecture is that there are very few tools available for analyzing the sequence. The behavior of each individual number in the sequence depends on the behavior of all the previous number, making it difficult to identify any general trends or patterns. Some researchers have attempted to use computer simulation to study the behavior of the sequence, but even with the help of computers, the problem remains highly challenging. Alright, so we're going to try some other number, for example, 2023 here, 2023, and the sequence goes to 1. Hope you enjoyed the video. In the meantime, please like, share, and subscribe to the channel.